had to factor and solve in class. And they are very different, and the methods that you're going to use to solve them are very different, but I need to make sure that you guys do remember, no matter what, when I'm looking at my binomials, I need to be able to recognize the parts that are there, and I need my equation to start off in standard form, and I need it starting off equal to 0. And if I don't have that, then I need to get there first. Once I'm there, I'm going to look for the parts that I've got. The a term is the thing that's in front of my x squared in my standard form. My b term is the thing that is in front of my x in my standard form. And my c term is the constant term that has no x. And so I need to be able to spot all three of those things, even with just the binomials when there's only two of the three, because they are different. Okay, the first one, I have an a term and I have a b term, but I don't have a c term. So I don't have the constant number that doesn't have an x on it. And when I know I have this to start off with, the very first thing that I'm going to do to proceed through this problem is look for a greatest common factor. That's what I need to find first, really every time I'm trying to factor, but especially with binomials. In those first two terms, the thing that I can evenly divide out of both terms, the greatest thing that they have in common would be a 5x. So I can divide both terms by 5x. I'm going to divide that out and put that factor in front. And it's all still going to be set equal to 0. The other set of parentheses is what's left over when I divided out the 5x. So if I divided 5x squared by 5x, all I will be left with is x, because 5x times x is going to get me x squared. If I divided a negative 10x by 5x, the only thing that's going to be left is a 2. And those are my two factors. From there, I just set them equal to 0 and solve. And there's my two solutions. The other type of binomial that you guys are going to be dealing with is when you have an a term and a c term and there's no b. Okay, and in this particular case, what I'm looking for is I'm looking for what the a term and what the c term were. If my a term, this one right here, is something squared, and my b term or my c term, this last piece, is also something squared, and there's a subtraction in the middle, what we call that is a difference of perfect squares. It's two different squares that are subtracted. That's what difference of perfect squares is. And the way that I'm going to factor this is using a little quick shortcut method. If I know what was squared minus what was squared, then it's a lot easier for me to factor and solve this thing down. In that first set of parentheses, I'm going to put in what was being squared to make 25x squared. Well, 5x times 5x is equal to 25x squared. And what was squared to be equal to 16? Well, 4 times 4, 4 squared, would be equal to 16, and I still have the subtraction there. Factoring this one is nice and easy. If I can recognize this piece and this piece, then I'm just going to use those two things in my parentheses to factor. The 5x is going to go first in both sets of parentheses. The 4 goes second in both sets of parentheses, and then I just need to go plus and minus. So I have a positive and a negative version that I'm going to be dealing with. From here, the solving method is the same as the last one. I set each one of these factors equal to 0 and solve. And it should be nice and easy for me to find my solutions. And there's those two. I hope this is useful for you. I hope you look it over. You can pause it, rewatch it as many times as you need. Please study. Good luck. I'll see you later.